Assalamu alaikum. Hello everyone. This is MJ Muhammad Jahangir Hussain. Today we are going to solve P3 from May June 23 version 32. Okay. So without any further ado, let's move on to the question. Okay. This is the question paper May June 23 version variant 32. Uh, Paper 3 Pure Mathematics Unit 3. So let's get to question number one. Question number one is solve the inequality involving modulus. In fact, you can solve modulus inequality in three different ways. That is, you can use the graph of the modulus on both sides of the inequality, then find the point of intersection, and from the graph, decide the region which satisfies this inequality. The other one is algebraic method, squaring on both sides to remove the modulus sign, then solve that quadratic inequality. The another one is simply find the point of intersection of these two curves, the one on the left hand side, the one on the right hand side. Then using the exponent of the point of intersection as critical values, then identifying the region is the critical values uh, divide the number line in three different regions. So which region satisfy the inequality? We'll check it out by taking a suitable value in that interval. So these are the three methods, but actually we are doing here the direct algebraic method, that is squaring on both sides. So let's square on both sides directly. The square on both sides, you have 5x minus 3 whole square less than 2 square plus 5x minus 7 whole square. So we have a quadratic inequality. Let's expand it. 25x square minus 30x plus 9. On the left side, we have 4 into 9x square minus 42x plus 49. Now, if you bring all the term on the left hand side, you have 25x square minus 36x square minus 30x plus 168x plus 9 minus 196 less than 0. So we have minus 11x square plus 138x minus 187. So divide by minus sign. Minus 11x square becomes plus minus 138x plus 187, and the sign of the inequality changes as well. Now, since it's a quadratic inequality, find the critical values. To find the critical values, you can use the middle term break, or you can use the direct formula to find the solve this equation. If you use the middle term break, it will be 187, that's 121 minus 121x minus 17x. You can use the middle direct formula solving. So x minus 11, take minus 17 common from the next two, that is x minus 11. That's 0. So we have two critical values here. Critical values are those for which this inequality becomes an equation. So x are 17 by 11 or 11. These are typical values and it's a quadratic inequality. You see, if you look at the final inequality, it's a quadratic inequality and this is greater. If it is greater and it's quadratic, so the region should be above x-axis. Since it is greater, these are the point of intersection, section 17 by 11 and 11. So this is the region. So set of x will be x less than 17 by 11 or x greater than 11. But while solving modulus inequality, we get to be careful. Sometimes the set of values of x we find using the algebraic method may be wrong. So you have to check whether these are the correct set of values of x. How do you figure out whether it is correct or not? Let's say we want to check out whether x less than 17 by 11 is correct or not. So now think of a number which is less than 17 by 11. So let's say let x equal to 1. And for x equal to 1, what is the left-hand side? What is the value of the left-hand side? You see, left-hand side becomes modulus of 5 into 1 minus 3, that's 2. And what about the right-hand side? The right-hand side, we have 2 times modulus of 3 into 1 minus 7. So it is 2 times 4, 8. So right-hand side is greater than the left-hand side. And our inequality says the right-hand side should be greater. So this region satisfies the inequality. So this region is okay. And x less than 17 by 11 a is a solution of this inequality. Now, what about the second region? When x greater than 11, let's take a number. An example, let's say x equal to 12 or x equal to 12, what happens to the left-hand side? Left-hand side becomes 5 into 12 minus 3. That's 60 minus 3, 57. What happens to the right-hand side? Right-hand side becomes 2 times modulus 3 into 12 minus 7, 36 minus 7, 29 into 2, 58. Yes, this is also okay. Right-hand side. So both regions satisfy this inequality. Therefore, set of x which satisfy this inequality, x less than 17 by 11 or x greater than 11. Both of the regions is uh, are the solution of this inequality. Okay, that question number 1 and marks is 4. But the thing is, I want to point out that whether this verification is not necessary or not. If both inequality, both set of x satisfy this inequality, then this verification is not mandatory. But if you have to discard one of the regions, then this verification is mandatory. Now, how do we figure out whether we have to show the verification or not? To check it, whether we have to give the verification or not, we'll check it using calculator. We'll just verify whether these two regions satisfy this inequality or not. Just do this in the calculator. If both regions satisfy, then don't show the verification in your working. If you have to discard one of the regions, then you have to show the working in your answer script. Okay, that's all about question number 1. Now let's move on to question number 2. Question number 2, you have to solve this equation, which is ln of 2x square minus 3 equal to 2 ln x minus ln 2, giving your answer in exact form. You see, you have to give your answer in exact form. That's the uh, that's an important point to note. So you cannot give your answer to decimal, okay, unless it is exact. So how do you solve it? Since it's an equation in logarithm, so we convert all the logarithm into single equation, single ln. Or on the right hand side, you can combine the two ln together. Okay, let's combine the two ln on the right hand side together. The left hand side, 2 ln of 2x square minus 3. On the right hand side, we need to combine the two logs. So what we do here, you have the coefficient of 2 with ln x. So what we do with the coefficient? Remember, if there is a coefficient in front of the log, we can transfer this coefficient as the power of the variable in log. So we'll do it here. It becomes ln x squared, then minus ln 2. Now to combine two different remember the formula, a base log p minus a base log q equal to, if you convert it into single logarithm, you have to divide the variable of a base log p, a base log of p by q. So on the right hand side, we will have ln x squared by 2. Now, this is both sides we have ln this and equal to ln that. Then, since these two ln are equal, so their bases are same. Since they are ln, the base is e, the variable must be equal as well. So, we remove the ln, just take the variable from both sides. These two are equal. Then from this one, we take 2x squared and x squared by 2 on the same side and the number on the other side. So we have 3 squared by 2 equal to 3. So x squared equal to 2. Now x can be square root of plus square root of 2 plus 1. But remember, x is a variable of the log. Yes, x is the variable of the log. It should be positive. It cannot be negative. On this one, it should be positive. So right here, but x greater than 0. So x equal to root 2. So that's the exact root of this equation. So that's question number 2. Now let's move on to question number 3. In question 3, you have to guess the locus of the points representing the complex numbers dates satisfying this equation. An Argand diagram, that is the modulus of z plus c minus 2i is equal to 2. That's part A. So let's draw the axis first. Now, see the locus representing the, what will it represent? This equation. This equation is the modulus of something is a constant, so it's a circle. The center of the circle will be, remember, the locus of circle is modulus of z minus z1 equal to a, where center of the circle is z1. Here, z1 is z minus inside bracket minus 3 plus 2i. So center is minus 3 plus 2i and the radius is 2. So it's a circle. The center will be okay. That's the center. And this is the center minus 3, 2. That's minus 3, that's 2. This is the radius. So this point is minus 1, 2. This is our real axis. This is imaginary. Okay. The next thing is find the least value of the modular z for points on this locus, giving your answer in exact form. Now, which z on this locus will have the least modular? Find it out. So what you do is simply join uh, the center of the circle with origin of the circle diagram by a straight line. And let's extend this straight line. Okay. So let's cut the circle at two different points. Here, and this. Among them, this Z is closest to the origin of the Argand diagram, so this has the least modular. So, and you have to find the exact value of this. To find this one, you remember from origin to the center, and find this length, which will be the modulus of Z1. So let's find modulus of Z1, which is root over minus 3 square plus 3 square, that's root 13, plus 3 square, that's root 13. So least modulus Z will be root 13, and you see this is the radius of the circle, and that radius equal to 2. So exact value of the least modulus of Z will be root 13 minus 2. So that's part B in exact form. Well, exact form. Okay. Next, move on to the question number 4. Okay. You have to solve this equation, trigonometric equation 2 cos x minus cos x by 2 equal to 1. So what are the key points here? The important points here is the angle. Angle of cos, the first cos has angle of x, the second one has an angle of x by 2. The angles are different. So what we do, we resolve this cos x into cos x by 2. Remember, if you use the double angle formula for cos, we have cos 2 theta equal to cos 2 theta has three different expansions. As one of them is cos square theta minus sin square theta. The second one is 2 cos square theta minus 1. And the third one is 1 minus 2 sin square theta. We'll use the one which we need here. The one we need here is we have to resolve cos x in terms of cos x by 2 using the double angle formula. So we'll use this one here, 2 cos square theta minus 1. How will we use it here? You see, here the x is equivalent to 2 theta and x by 2 is theta. So for this cos x, we have two brackets For this cos x, it becomes 2 cos square x by 2 minus 1 minus cos x by 2 equal to 1. So now we have angle x by 2 for both cos. Now we have a quadratic equation in cos x by 2. So solve it to find the value of the cos x by 2. So let's take all the term on the left hand side and simplify it. We have 4 cos square x by 2 minus cos x by 2 minus 2 minus 1, that's minus 3. So you can do the middle term break here, or you can find the value of cos x by 2 directly using the calculator. Okay, I'm doing the middle term break here. Okay, I'm not explaining how to do this middle term break. I'm directly solving it. So we have, after factorizing, we have cos x by 2 minus 1 into 4 cos x by 2 plus 3. So we have two different set of values for different value for cos x by 2. One of them is 1, the other one cos x by 2 minus 3 by 4. Now, to solve it, we see the set of values of x, the values of x in the power to cycle. So the set of values of x for x by 2 will be 0 to pi. So that includes the first and second quadrant only. Now cos x by 2 is equal to 1. So you find the basic acute angle for this one. Cos inverse 1 is 0, 0 radian, and between these two, cos positive is in the first quadrant always. So x by 2 will be equal to, in the first quadrant, the angle is equal to basic acute angle, which is 0. So x is 0 from this one. And here, the second set, we have cos x by 2 equal to minus 3 by 4. So it's negative. And among the quadrant, it lies in the second quadrant. So the second quadrant means to find the angle in the second quadrant, first find the basic acute angle cos inverse 3 by 4. Remember, we find it in radians. So use the radian mode of your calculator. That is 0.7273. So x by 2 equal to, in the second quadrant, the angle is equal to pi minus basic acute angle. So x will be double of this. And final answer in radians, in non-exact answer should be left correct to 3 SS 4.84. Right. So we have two different values for x here. But then x is 0, the other is 4.84. These are the two values of x, which is the solution of this, which are the solution of this equation. Okay. Now let's move on to the next question. Okay. Now, this is in question number 5. We see the complex number 2 plus yi is denoted by a, where y is a real number and y is negative. It is given that function of a, if a is a cube minus a square minus 2a. Find a simplified expression for f a in terms of y. So you have to find FA in terms of Y, where A is equal to 2 plus yi. In, in the function you see we have a square and a cube. So why don't we find a square and a cube first? Let's find a square. A square is 2 plus yi whole square. That is 4 plus 4yi plus y square I square, which is 4 minus y square plus 4yi. Okay. Then what about a cube? A cube is 2 plus yi whole cube, and you can write it as 2 plus yi whole square, 2 plus yi, so that 2 plus yi whole square is 4 minus y square plus 4 yi, 2 plus yi. Now multiply it. 8 minus 2y square plus 8yi, then 4yi minus y cube I, then we have 4y square I. So the real parts are, what are the real parts here? 8 minus 2y cube y square, and here minus 4y square. So we have 8 minus 6y square. Remember, remember, I square here is I square equal to minus 1. So that is minus 4y square. And in case of I, we have 8yi plus 4i, that is 12yi minus y cube. So 12y minus y cube I. Now find f of a. That is a cube minus a square minus 2a. Substitute the value. A cube is 8 minus 6y square plus 12y minus y cube I. A square is minus 4 plus minus a square. So it will be minus 4 plus y square minus 4yi, and minus 2a, it becomes minus 4 minus 2yi. Now simplify. So take all the real parts together. 8 minus 6y square minus 4 plus y square minus 4, and the imaginary part together. Imaginary part we have 12y minus y cube minus 4yi minus 2yi. Okay. Now simplify it. We have minus 5y square, and here we have 6y minus y cube. That's the simplification, and for all this working, the total mark is C only. So minus 5y squared, 6y minus y cube I. So that part A, we have simplified uh, the expression for f of A in terms of y. Now, what about the second part? In second part, you see real part is equal to minus 20. Real part of the expression f of the function A is minus 20. You see the real part of function A here. This is the real part. This is equal to minus 20. So we have minus 5y square equal to minus 20. So y square equal to 4. And remember, y is negative. Don't forget it. y is negative. So y is minus 2. Reason as y less than 0. In that case, we have to find the argument of a. In that case, a is, what is a? A is 2 plus yi. So 2 minus 2i. Argument, the argument, it lies in which quadrant? X positive, real part positive, imaginary part negative. So it lies in the fourth quadrant. In fourth quadrant, argument is minus alpha. So arg A, argument of A is minus tan inverse the basic acute angle. You see the basic acute angle is here. This is 2, this is minus 2. So that angle, so 2 tan inverse 2 by 2. Basic acute angle, that's positive. So minus tan inverse 1, pi by 4. So minus pi by 4 is the argument here. That's part B. What about, is there any other part? No. That's part A and part B. Total mark in this question is 5. E plus 2, that's 3 plus 3, that's 6. Sorry, my bad. Total mark in this question, number 5 is 6. Now let's move on to the next question, which is 6. Here, the equation cos x by 2 equal to thrice x has one root in the interval 0 and pi, denoted by alpha. So by calculation that alpha lies between this. So by calculation, you have to show that alpha lies between 0.5 and 1. To show this, let's convert or let's transfer all the term of this equation on the left-hand side. So, and afterwards, we'll consider it as as fx or x by 2 minus twice x, that's fx. Now calculate f of 0.5 and f of 1. If 0.5 gives, remember calculator must be in radians. Here the angle, and of the angle is in radians. So this is positive 2 point, positive 2.416. And what happens when f of 1, if you find f of 1, 1 by 10, that is, it becomes negative. Since sign changes, root lies in the interval. Interval is 0, 0.5 to 1. Right. That's part A, numbers. Then part B. So that if a sequence of positive values given by that formula converges, then it converges to output. If the sequence of positive values given by this converges, then it converges to alpha. That is, you have to show that our original equation can be, from our original equation, we can rearrange that original equation into this formula. Here, the alternative formula, if we remove n and n plus 1, this is x equal to 1 by 3, x plus 4, tan inverse 1 by 3 x. Okay, if you can show this one by rearranging our original equation, then it will prove this statement. So our original equation is cos x by 2 equal to 3 from this one. Okay. So you have to have 10. So we divide this cot 1 by 10 by 2 by 6. So we have 10 x by 2 equal to 1 by 6. And to write x by 2 is equal to 10 inverse 1 by 6. From this one, what do we have here? X equal to 2 10 inverse 1 by 6. But you see, the statement we have to show is different from this one. If you multiply, we have 6 equal to x plus 4 10 inverse 1 by 3x. This one suggests that you can multiply both sides by 2 so that we have 6 equal to 4 10 inverse 1 by 6. Then rewrite this 6 as 6 minus 6. Then 6 is equal to x plus 4 10 inverse 1 by 6. So x equal to 1 by 3 bracket x plus 4 10 inverse 1 by 6. So you don't need to write any more word here. That's enough. Then we have used this as the iterative formula here by substituting by changing the x on the left hand side by xn plus 1 and the x on the right hand side by xn. That will be the iterative formula. Okay, that's question number 6b. Okay, let's move on to the next part. Then C, use this iterative formula to calculate the value of alpha correct to two decimal places if the result of each iteration to four decimal places. You see, starting value of x is not given here. So you have to consider it. Uh, you have to assume the starting value of x yourself. And normally, whenever the interval is there, we consider the midpoint of this interval as the starting iterative, starting approximation, starting value of x. So let's first write down the iterative formula for here. Xn equals 1/3 bracket xn plus 4 tan inverse 1 by 3xn. Okay, that was the iterative formula. You see, xn plus 1 is 1/3 plus this, and starting value of x is not given. Let's assume the midpoint of the interval in which the root lies as the first approximation. 1 5 plus 1 divided by 2, that's 0.75. Now find x2, simply substituting xn by 0.75. see x2, you need to write x2 correct to 4 decimal place. 2 becomes 0.8076. X3 is 0.7911. X4 is 0.7954. X5 will continue until two consecutive value of x matches back to two decimal places. 4, 3. So here you see x4 and x5 both are equal correct to two decimal places. No, no, no. Sorry, my bad. So x4 is 0.80. X5 is 0.79. So the next one is x6, 0.7946. Okay, this one is 0.79. So alpha, which is the root of the equation, is 0.79. Correct to decimal place. So that's the root of the equation in the interval 0, 0 and 1. 0.5 and 1. Okay, let's move on to the next question. Question number 7. The equation of a curve is given is 3x square plus 4xy plus 3y square equals 5. So that dy by dx. So this is implicit equation, and you have to find dy by dx in terms of x and y, and exactly in this form. So let's differentiate implicitly. Let's write the equation first. Again, first 3x square plus 4xy dy square equal to 5. Now, if you differentiate the first term, we have three differentiation of 3x square is 6x. Then the next term, we have product of x and y. So we'll apply the product rule here. The differentiate 4x into differentiation of y. Differentiation of y is dy by dx plus y into differentiation of 4x, which is 4. That's the differentiation of 4xy. Then if you differentiate 3y square, it becomes 6y. Since it's a function of y, so we'll write dy by dx as a product with this. So 6y dy by dx. And on the right hand side, we have 5. It's the constant. Differentiation of this is 0. Now, so combine the dy by dx together 4x dy by dx plus 6y dy by dx. And let's take remaining terms on the right side minus 6x plus 4y, minus 4y, minus 6x minus 4y. Then we take 4x plus 6y common on the left hand side. The right hand side, take minus 2 common, so that's 5x plus 2y. 2 times 5x plus 5y. So dy by dx is minus 2 5x plus 2y, and it takes 2 common here, 5x plus 3y, and divide this. So dy by dx equal to minus 5x plus y divided by 12x like y. So that's 7x. Now let's move on to the next part, part B. What do we have here? Hence, find the exact coordinates of the 2 points in the curve at which the tangent is parallel to this. In this line, what is the gradient of this line? If you make y the subject, y equal to minus 2x, so this line has a gradient of minus 2. The gradient of tangent is minus 2. You see, gradient of tangent is equal to the gradient of curve at that point of contact. So dy by dx equal to minus 2. Now, remember dy by dx minus the numerator is 5x plus twice y, numerator is 5x plus twice y, and the denominator is twice x plus twice y equal to minus 2. So equals multiply 4x plus 6y by 6 plus 2y. So we have x equal to minus 4y. That's an expression. X is equal to minus 4y at a point where the tangent to the curve is parallel to y equal to minus 5x. Now, to find the exact coordinate, you have to substitute x equal to minus 4y in the original equation. The original equation is sin x square plus 4xy plus sin y square equal to 5, right? Okay, now substitute x equal to minus 4y here. So we have 3 into 16y square, 4x into minus 4y, that is minus 16y square plus 3y square equal to 5. So 48 plus 3, 51 minus 6, 25, right? 48 minus 16 plus 3, 35. 35 y square, 25. So y square is 1 by 7. So y equals to plus minus square root of 1 by 7. That is plus minus 1 by square root of 7. Now x is, no, y is 1 by root 7. X is minus 4y. So x is minus 4 by root 7. When y is, when y is minus 1 by root 7, x is plus 4 by root 7. So there are 2 points on the curve at which the tangent is parallel to that given line. The coordinates of these 2 points are these two. That's it. That's the part B. Now let's move on to the next part. 8a, the variables x and y satisfy the differential equation. This one is given that y is 0 when x equal to 1, solve the differential equation, obtaining an expression for y in terms of x. It's important to note that you have to make y the subject of this expression, of the particular solution. So let's solve it. First, separate the variable. If we separate the variable, we have here 1 by 4 plus 9y square into dy equal to 1 by e to the power twice x plus 1 to dx. Now we'll integrate on both sides. To integrate on both sides, here on the left hand side, you have to take 9 common, right? If you take 9 common here, we have y square plus 4 by 9. And here on the right hand side, you have to bring the denominator in the numerator so that it will be e to the power minus 26 minus 1. Now bring this 1 by 9 outside and it is dy y square 2 by 3 square. The right hand side we have e to the power minus 26 minus 1. 3. Now integrate. Remember integration of 1 1 by a square plus y square dy equal to 1 by a tan inverse y by a, okay, plus c. So we have here 1 by 9 into 1 by a, 2 by 3, tan inverse y by 2 by 3. On the right hand side, we have e to the power twice x, remember, integration of e to the power x plus b is 1 by a to the power x plus b. So it will be 1 by minus 2 e to the power minus 2x minus 1 and then constant of integration on the right hand side. So it is 1 by 6, let's take that 6, 1 by 6, tan inverse dy by 2 equals to c minus half e to the power minus 2x minus 1. Now use the boundary condition y0 x1 when x equal to 1, y equal to 0. To substitute it in this equation. So we have 1 by 6, tan inverse 3 into 0 by 2. So tan inverse 0, that's 0. C minus half a to the power minus 3. So from this one, we have C equal to 1 by 2 half a to the power minus 3. Okay. Now, let's say we substitute the value of C 1 by 6 tan inverse dy by 2 equal to half e to the power minus 3 minus half minus 26 minus 1. So it is tan inverse. Remember, you have to make y the subject. E by e cubed minus e by e to the power 26 plus 1. Now, dy by 2 equal to tan e by e cubed minus b by e to the power 26 plus 1. So, y equal to 2 by 3 tan e by e cubed minus e by e to the power by 6 plus 1. That's question. That's part A. Then in part B, is there part B? Yes, there is part B. Let's move on to part B. What does it say? Show that. So state what happens to the value of y as x tends to infinity. X as x increases. Let's see. Y is 2 by 3 tan of p by e cube minus p by e to the power 2x plus 1. As x tends to infinity, what happens? P by e to the power twice x plus 1 tends to 0. Then y becomes 2 by 3. Y tends to y approaches this value 2 by 3, then p by q. That's it. That's the and you have to give this and give your answer in exact form. So this is the answer. So that's part B. Now let's move on to the next question. This question is partial fraction and is it proper or improper? If you look at the fraction, if we need the highest power in the numerator is 2, which is less than the highest power in the denominator, which is 3. 2 less than 3, so it's proper. So we don't need to express this fraction in the mixed form. We will directly use the partial fraction. So partial fraction will be, how many fraction will be there? Since the number of linear factor in the denominator is 3, so we'll express into 3 fraction. In partial fraction, there will be 3 fractions. So a by 1 plus y x, and in the denominator is the 2 minus x repeated twice. So you have to take 2 minus x single first, then here. That will make 3 fraction on the right side. Now, if you multiply both sides by the denominator of the left-hand side, we'll have x square plus 17x minus 17, while you are multiplying a by 1 plus 2x by the denominator. The left-hand side, a plus 1 plus 2x cancel out, so with a, it remains 2 minus x whole square. And b, in case of b by 2 minus x, if you multiply it by that, you have b times 1 plus twice x into 2 minus x. In case of c, we'll have c times 1 plus 2x. Now, to find the value of a, the constant a, b, c, use the shortcut value. The first shortcut value is x is 2. The shortcut, remember the shortcut value for which the denominator of the original fraction becomes 0. See? Here, if you for x equal to 2, this part becomes 0, and here x equal to minus half, this part becomes 0. So these are the shortcut values to find the constant. So let's first use x equal to 2. If you use x equal to 2, left hand side becomes 8 plus 17 into 2 minus 17, that's 25. On the right hand side, we have a times 0, b times 0, c times 5. So 5c, c is 5. Then to find the value of another constant, let's use the second shortcut value, which is minus half. If we substitute minus half, it becomes, left hand side becomes 2 into 1 by 4, that's half minus 17 by 2 minus 17, so that is minus 25. And the right hand side becomes a times 25 by 4, 25 a by 4, b times 0, c times 0, so a is minus 4. Now you see we have one more unknown remaining, and we have uses the shortcut. We have used these two shortcut values of x. Now you substitute any value of x other than these two. So let's say when x equal to 0, substitute x equal to 0, the left hand side becomes minus 17, right hand side becomes 4a plus 2b plus c. Now you know the value of a and C. Substitute them. So 2B minus 6 will equal to minus 3. Now we know the value of the constant A, B, C. Substitute them and you have the partial fraction 4 by 1 plus 2x minus b by 2 minus 6 plus 5 by 2 minus 6. Okay, that's the partial fraction. So let's move on to question number B. Here you have to integrate f and you have to show that this definite integral is exactly equal to 5 by 2 minus ln 70. So to show this one, let's start with the partial fraction. Partial fraction is remember minus 4 by 1 plus 2x and minus 3 by 2 minus 6, then plus 5 by 2 minus x whole square. Here. So you use the integration. Let's start the integration directly. Remember the formula we'll be using here 1 by integration of 1 by x plus b is 1 by a ln of x plus b. And the second one we'll be using here x plus b whole to the power n dx is x plus b whole to the power n plus 1 divided by n plus 1 into the constant of integration, okay, plus c. But we will not use c here because it's the definite integral. So 4 divided by 2 coefficient of x ln 1 plus 2x is minus 3 divided by minus 1 ln 2 minus 6 plus 5. This will be treated as 2 minus x whole to the power minus 2. So 2 minus x whole to the power minus 2 plus 1 minus 1 divided by new power and the coefficient of x. So that's the integration. The limit 0 and 1. So you have minus 2 ln 1 plus 2 is 6 plus 3 ln 2 minus 6 plus 5 by 2 minus 6. Now substitute the limit. So the substitute the upper limit, it becomes 2 ln 3 plus 3 ln 1. Remember, ln 1 is 0. And this is 5. Substitute 0. X equal to 0. We have minus 2 ln 1, which is 0. Plus 3 ln 2. And this is 5 by. So we have 5 minus 2 ln 3. That is ln 3 square. 3 ln 1, that's 0. Plus 2 ln 1 is 0. Minus 3 ln 2, that is ln 2 cube minus 5 by 2. Now 5 minus 5 by 2, that's 5 by 2 minus ln 9 minus ln 8. So let's take minus common. If you convert into a single ln, 5 by 2 minus ln 9 into 8, that's 72. Okay, so Let's start here. Okay, guys, let's move on to the next question. That's the end of this. And the diagram shows the curve, this, and its maximum point is M. Find the exact coordinate of M. So, to find, since it's the maximum point, so its stationary point dy by dx is 0, first find dy by dx. So, to find dy by dx, we need to rewrite the equation in index form. Now differentiate dy by dx, x plus 5, differentiation of the second term. Remember product rule, dx of u v. U, the differentiation of v plus v, differentiation of u. So this is u, this is v. The differentiation of v is here half u. A power is half minus 1, that's minus half, into differentiation of v base with minus 2. Differentiation of p minus twice 6 is 1. Okay. Next, v unchanged. The differentiation of u, which is x plus 5, differentiation of that is 1. Now we have done complete the differentiation. Let's simplify it. Minus x plus 5 into, let's put the minus sign first, p minus twice 6 to the power of minus half plus p minus twice 6 to the power half. Okay, and do the same. P minus twice 6 to the power half minus x plus 5 divided by p minus twice 6 to the power half. Now, if we do the LCM, then this one, its denominator was 1, so you have to multiply the denominator with the numerator here, so it becomes 3 minus twice x whole to the power half plus half, that's 1, minus x minus 5. So, this is equal to uh, minus twice x minus 2, 3 minus twice x to the power half. Now, dy by dx equal to 0. If you set dy by dx to be 0, we have minus twice x minus 2 divided by 3 minus twice x to the power half to 0. That is minus twice x minus 2 equal to 0. That is x equal to minus 2 by 3. So that's matches with the diagram. The diagram says that the coordinate of the turning point is negative, and it is negative. So minus 2 by 3. Once you know the x coordinate to be minus 2 by 3, then you find the y coordinate. Y coordinate will be substitute x equal to minus 2 by 3 here, 5 minus 2 by 3, the 15, 13 by 3, and that is 3 plus 4 by 3, 13 by 3 equals 13 by 4, 3, that is 13 root 3 by 3 root 3. If you multiply by root 3, it becomes 13 root 39 divided by 9. So the exact coordinate of n minus 2 by 3, 13 root 39 divided by 9, that's the one. That's the exact coordinate of m. Okay, now let's move on to the next part. In the next part, what you have to do, you have to find, using the substitution, 3 minus twice x, find by integration the area of the shaded region bounded by the curve and the execute, give you your answer in this form, a root 3, where a is a rational number. You see, the area, look at the diagram. Area will be from this point to this point, integration of yt. So you need to find the x-intercept first. So y, which is x plus 5 times 3 root 3 minus 2 root over 3 minus 2 So y equal to 0 is x equal to minus 5 and 2 by 2. Then area, integration of y dx, y is that one, x plus 5 square root of 3 minus twice x dx, lower limit minus 5, upper limit 3 by 2. Now, you see, you have to use the substitution. U equal to 3 minus twice x. Then du by dx becomes minus 2. So, dx is equivalent to du by minus 2. Now, to change the limit, when x equal to minus 5, u becomes 13, and x equal to 3 by 2, u becomes 0. So, area now lower limit becomes 13, upper limit becomes 0, x plus 5 root u, and dx is du by minus 2. Now, one thing, everything except x plus 5 has converted into u. Now, to convert x plus 5 as u, so you have to make x subject from here. Plus x equal to 3 minus u. So, x equal to 3 by 2 minus u by 2. Substitute it here. Minus half 13, 0 is p by 2 minus u by 2 plus 1 into u to the power half d. Now remember, if you multiply the integral by negative, the limits changes. Okay. So lower limit becomes upper limit becomes lower limit. So half times this is uh, 13 by 2 u to the power half minus half u to the power 3 by 2. Now integrate. You can multiply by half first. So let's multiply 13 by 4 u to the power half. Integration of this is 3 by 2 e to the power 3 by 2 by 3 by 2 minus 1 by 4 u to the power 5 by 2 divided by 5 by 2. That's the integration and the limit. Now substitute the limit. This one has become 13 by 6 into 13 to the power 3 by 2 minus 1 by 10 into 13 to the power 5 by 2. That's upper limit minus lower limit. If we substitute the lower limit, this thing becomes 0. And 13 by 6 into 13 to the power 3 by 2. 13 to the power 3 by 2, that's 1.5. 13 to the power 1 is 3. 13 to the power half is root 30. Minus 1 by 10, that's 13 to the power 2 plus half. 13 to the power 2 is 13 square, 169. And 13 to the power half is root 30. Now, do the LCM here. 6 and 10, LCM becomes 30. So, let's take 169 root 13 common. Okay. 169 root 13 by 6 minus 169 root 13 by 10. So, 169 root 13 common, then 1 by 6, 1 by 10. That is 1 by 15. So 169 by 15 root 30. That's it. That's the exact area. Okay. So this is the sum. I hope you have understand everything. You have understood everything. It's clear to you. So let's move on to the next one. This is a vector. Sum from vector. The points A and B have position vector this and this, and the line has equation this, so that L does not intersect the line passing through A and B. So first of all, we have to find the line passing through A and B. Let's roughly draw. There is A and B. So to find the line, we need the direction, and we'll use one of the point at the position vector of the line. So, and remember, equation of the line is in the form R equal to A plus lambda into B is the direction. Here, AB vector will treat the AB vector as the direction. AB vector will be B, OB, position of B minus position of A, position of B, which is, let's write it as column matrix, column vector, 2 minus 1, 1, that's position of B minus position of A, 1, 2 minus 2. So, the direction becomes 1 minus 3, 3. Equation of line AB is R A, one of the point as the position. Let's consider the first point, 1, 2, minus 2, plus lambda into B, 1 minus 3, 3. Now, we have to show that these two lines does not intersect, AB and L. Now, whether two lines intersect or not, we have to convert it as a position vector form, 1 plus lambda, 2 minus 3 lambda, minus 2 plus 3 lambda, that's line AB. And the line L, if you convert it into position vector form, single column, it becomes 1 plus 2 mu minus 1 minus 3 mu, that's 3 plus 4 mu. Now, whether they intersect or not, what we do is simply equate. Equate x 1 plus 2 mu equal to 1 plus lambda. So we have lambda equal to 2 mu. Now equate y, you get another equation. Let's name it equation number 1. The second equation becomes minus 1 minus 3 mu equal to 2 minus 3 lambda. Now substitute lambda equal to 2 mu here, 2 minus 6 mu. So that is 3 mu equal to 3 mu equal to 1. Mu is 1, then lambda equal to 2. Now we have to check whether this value of lambda, this set of values of lambda and mu satisfy the third condition or not. To define the third condition, use the date because we have equated already x and y. Now you have to verify whether z coordinate are corresponding to these values of mu and lambda are matches or not. Z1, let's say the z coordinate from the line AB is Z1 minus 2 plus 3 lambda into 2, that is 4, and Z2, that's the z coordinate from L, 3 plus 4 into 1, that's 7. This two does not match, different. Therefore, they do not intersect. Okay, these two lines do not intersect. That's fine. That's what we have to show here. Now, let's move on to the next part. Find the position vector of the foot of perpendicular from A to L. Remember, let's roughly draw the diagram. A is here and L is there. Now, position of A 1, 2, minus 2. 1, 2, minus 2. An equation of L is given as this one. L as the equation R equal to, what is that? 1 minus 1, 3 plus mu into its direction. Direction is 2 minus 3, 4. 2 minus 3, 4. Now, we have to find the position of the foot of perpendicular from A to L. So that is the foot of perpendicular. Let's name it P. Have to find the coordinate of P on this perpendicular. Now P is a point on the line. P lies on L. And we'll find the position of P. So let's assume P lies on the L. So the position of P is the parametric form of the line L. Now we'll find the value of mu corresponding to the value of coordinate of corresponding to the point P, since P lies on this line. And for that, we know that AP is perpendicular to L. So find AP first in terms of mu. AP is OP minus OA. So it is 1, 2 minus 2. It becomes 2 mu minus 3 minus 3 mu. It becomes 5 plus 4 mu. Now we know that AP is perpendicular to L, since AP is perpendicular to L, so direction vector of L and AP dot product of these two will be 0. AP is perpendicular to L, so dot product of AP and direction vector of L, direction vector of L equal to 0. And we have AP as 2 mu minus 3 mu plus 4 mu dot direction vector of L is, you see, the direction vector of L 2 minus 3, 4. Dot product of these two equal to 0 because they are perpendicular. So 4 mu plus 9 plus 9 mu plus 25 plus 16 mu equal to 0. So we have 29 mu plus 34 equal to 0. My bad. Here I made a mistake. Here it is 20 plus 29 equal to 0. Therefore, mu equal to minus 1. The position of P will be substitute develop mu in the position of P. So minus 1. So this is minus 1. P minus 1, 2. That's minus 1. So that's the position vector. Or you can write it in ij form minus I plus 2j minus k. That's the position of the foot of the perpendicular. That's part B. Is there any further part? No, that's all. That's the end of this paper. I hope you all understand. If you have queries, please mention in the comment section. You can also contact me by the email provided in the contact. So that's it. Until the next video. See you. Allah Hafiz. Assalamu alaikum. Fi aman.